So we've been, excuse me, talking about organizing qualitative data. Now we'll go on and talk about quantitative data. And there's a lot of similarities in how you organize qualitative data. Like qualitative data, quantitative data is summarized using a frequency distribution. And then the frequency distribution is represented graphically using something called a histogram, which is actually very similar to a bar graph. Okay, so for example, the following frequency distribution lists or gives the number of adult Timbuktu village residents of various ages. Okay, so there you go. That's data that's been recorded as a frequency distribution. So the data values, ages, are grouped into intervals that are called classes. So classes are similar to categories, except they're intervals that represent groups of data values. Now, the lower number in each class we call the lower class limit. So 20, 25, 35, 45. Okay, so those are the lower class limits. So for this example, the lower class limits are 15, 25, 35, 45, 55, 65, and 75. The upper class limits are the upper numbers you see for each class. Those are called upper class limits. So 24, 34, 44, 54, 64, and 74 are the upper class limits. Now the class widths are how wide the classes are, but what we're actually not going to do is we're not going to say, oh, this width is 9 because it takes, 24 minus 9 is 15. What you want to think of the widths as is the difference between successive lower class limits. So the difference between 25 and 15 is 10, and each of these class widths is 10 because there's a difference of 10 between each of the lower class limits. Now, let's talk a little bit more about what's going on there with that. The classes do not overlap, and that's really important because you don't want confusion about which class a particular data value belongs to. So we're not going to say 15 to 25 and then 25 to 34, because then it would not be clear which class 25 belongs to. And then we can make a histogram for this frequency distribution. And by the way, I should perhaps have put frequency here. Okay, but we can make a histogram for this. Now, as I said, histogram is really similar to a bar graph. We're going to have the frequency on the vertical axis. We're going to have the horizontal axis for the variable we're measuring, which is resident age. And then we're going to label the horizontal axis with the categories. Now, what's different here is that the rectangles or bars are going to touch each other. So I'm going to put the lower limits in, 15, 25, 35, 45, 55, 65, 75. And I don't have anyone of age 85, but let's put that in. And then let's see, the frequencies. What do we have for these? They go up to 60, so I need my vertical axis to go up to 60. So let's see, if this is 60, 30 would be about there. So I'd have 20 and 10, and 40 and 50. Okay. Okay, so residents who are age 15 up to anything less than 25, there's 10 of those. Okay, so I'm going to make a bar, a rectangle that goes from the 15 to the 25. And then it just has to be understood that 25 actually belongs to the next class. Let's see, 25 to 34, there were 30 people. The frequency was 30, so I'm going to have my rectangle go up to 30. 35 to 44, there were 50 people. That's about that high. For people ages 45 to 54, there were also 50 people in the village, so the frequency was 50. For people aged 55 to 65, 40 people of that age. And people 65 to 74, there were 60 people. That's that high. And then for people ages 75 to 84, and there were only 20 people. Okay, so there we go. That's the histogram for the frequency distribution of these adult residents of this village. Okay, frequently asked question. Again, because the histogram looks so much like a bar graph, it's easy to get confused about which is which. So what's the difference between a bar graph and a histogram? Well, a bar graph is used to represent qualitative data, whereas a histogram represents quantitative data. And the rectangles in a bar graph do not touch, but the rectangles in a histogram do touch. That's even though the classes are not actually overlapping. Now, in the example we just looked at, we were given a frequency distribution. What we're going to look at next is, what if you're not given the frequency distribution, but just given the raw data? How do you come up with a frequency distribution? And we'll do that in the next video, so I'll see you then.